really grateful and thankful to Mithilesh Mishra sir, DM, and of course, basically my guru, Professor Anil Kumar sir. Actually, I started my work. I am a geophysicist. That geophysics deals with any non-invasive characterization of the Mother Earth, just like what the doctors, what the pathologists, what the radiologists they do. That geophysics do for the Mother Earth to unravel, to characterize that subsurface. What under the subsurface is, what the subsurface going to happen. It deals with that exploration, energy resources. It deals with the groundwater exploration. It deals with mineral exploration, oil exploration, any energy resources to any hazard like landslide, subsidence, that any kinds of hazard, any kinds of whatever the mining activity is going on, starting from the groundwater to mineral to hydrocarbon, oil, and after the exploration, what is going to happen to the Mother Earth, what are the side effects, all deals with the geophysics is a tool that can give some understanding about the happening and can suggest the remedial measures. Okay, so it is just kind of pathologist or radiologist that the doctor take help before going to any treatment. So just I am a geophysicist, and basically I started my career from mathematics honors from very village background, and from the beginning that I feel that students are fortunate enough that to get this kind of exposure from this platform, that what I don't had it. That I was really very enthusiastic to learn something, to get ideas, lot of things, but in our time it was not the case. So basically I think that the students mainly you are fortunate enough to getting this type of exposure, and you are sitting in the heart of the that culture, that heritage that gives basically I am background of science, but I talk to my students in class that science is totally based on the history, totally based on the, without history science is impossible. Okay, so that I started my career in archaeology, apart from mineral exploration, groundwater exploration, then different geotechnical investigation regarding the bridge construction, road construction, to that archaeology, that because I want to explore the geophysics, the tool in different aspects. It is a basically multidisciplinary tool that can be utilized to address different problem for betterment of the society, betterment of the nation, for understanding in better form. So that I will start with my topic, the revealing hidden heritage around Lakhisarai through the integrated geophysical survey that started in 2018. I can remember I was on that leave in Durga Puja vacation in my home. That time Professor Anil Kumar called me, and really I thrilled with his call that I got an opportunity. It was a dream to work in archaeology. So that we visited with my entire team, that basically Department of Applied Geophysics, IIT ISM Dhanbad, that very well equipped with all possible geophysical tools, just like scanner, ultrasonography, any kind of that medical testing unit. So Mother Earth testing unit, that is the geophysical instruments, that Department of Applied Geophysics, IIT ISM, we have it. And I try to utilize most of them in an integrated approach. So we first visited Lakhisarai in 2008 That time we conducted multiple geophysical study, and really that lot of interesting that features we could identify it, but until the basically whatever the features we identify in terms of a geophysical anomaly or geophysical signal. So that geophysical signal, just like our goddess, that statue, the Durga Mata or any other goddess, until unless it is been कोई पूजा करके उसका आई उसको लाइव बनाया जाए, so that need one archaeology that Professor Anil Kumar did it. So I start with that basically to have the sense that just before me that professor that told about there are huge potential to explore and different other sites around the Lakhisarai, that I also believe that one regional study that in general we conduct, that is a remote sensing study. And with the advancement of the remote sensing and different other data product in GIS platform, we could utilize them better using the recent tools, that is AI ML, that artificial intelligence that inputs all the different data product can be considered to identify more potential sites surrounding a specific region that we attempted. That first is that remote sensing gives an bird eye view of for identifying the different mounds, different elevated area, and also tells the different association with the nearby river, distance from the river, that slope, then urban area, road network, and that also tells with the connectivity of the whatever the recent different religious places are there, so that association can be linked and altogether can be analyzed and can be utilized for further interpretation of other potential sites. So similar type of study been carried out in part of Chhatra, Hazaribagh and Ramgarh district. This is one case study. So we consider different multi-data product in addition to the satellite image product, different satellite data product like elevation model. That elevation model deals with the topography distribution in the surface. So from that we could able to identify some distinct something different anomaly feature that we call the mound that can be associated with the archaeological potential sites. So we try to attempt by integrating different multi-data product from the starting, considering the distance from the road, distance from the river, distance from the ponds, then geology, then slope aspect, like that. So many different parameters we consider. These are the different layer data product, and using that layer data product we could able to identify one that low potential that blue indicates the highest potential zone for the possible archaeological important site. So after that we could able to identify with the field visit with our team that some potential site additionally identified. That similar study we are also planning in this area. So basically that geophysics already I have briefed that non-invasive site assessment can only be possible by geophysical tools. That geophysical, there are different multiple tools that basically it deals with the identifying and mapping the subsurface feature, subsurface structures or artifacts, and that subsurface structure artifacts always may not be are all indicating the archaeological lineaments. So we have to infer according to the specific sites. Then that imaging technique can give you very fast and very time efficient, cost effective, fast forward identification of different features in a site, and then we can utilize for preservation, and then different tourism and other development in the area. So that in general we basically utilize different geophysical tools, but among the different tools that most widely utilized is the magnetic method, then electrical resistivity tomography method, and then ground penetrating radar. That magnetic method, it deals with, I feel that all the students, they know, they have covered in their school that what magnet is, what magnet basically, that any magnet have one property, one religion. We are talking about religion. Religious or religion is nothing but its property, its specific features, how we can define a feature. So that magnetic property is one feature, one character of a material, that in general most of the features, they don't exhibit any magnetic property in general, but they have magnetic property, but they are in balanced condition. Okay, so that all, it can be considered that a large amount of that in atomic level, large number of that that magnetic materials are there, and they are in north-south, that positive, negative, they are in balanced condition. But few material, according to that local earth magnetic field, they gain some magnetic property in large or low. So that how large or how low, that we basically try to understand in terms of that material characterization. In general, that some ferrimagnetic material, we call that material which attain or which that gain magnetic field very high, positive, they are magnetic material, and some other material they don't gain, so they are relatively low magnetic. Okay, so in magnetic, that earth is in general, earth is a huge magnet, and that north pole, south pole we know. So that in general, in an area, if it is kept, if it is for an example, that in general, that iron is a magnetic material. Okay, so any metallic material, not all the metallic material exhibit the magnetic property equally. They have different magnetic properties. Okay, so in general, in archaeology, that any material that is burned, like bricks, if it is burned, then during the baking, it lost entire magnetic property. But once it is cooled down, it gains the very high magnetic field where it been kept for a long period. Okay, so that is the property we are going to analyze for the archaeological interpretation, if it is bricks or if it is any that iron material or any other magnetic material or not. Then coming to the GPR, that is ground penetrating radar, that the basic principle is that there is one transmitter and receiver. So the transmitter and receiver both are housed in a single, there are different types of instruments, but in generally for archaeological investigation, we utilize relatively high frequency GPR that deals with that emitting of electromagnetic signal and then receiving of the reflected electromagnetic signal from the subsurface. Just like whatever we are looking each other, that light incident on me and reflecting back from me, and if all the lights in the house, if it is switch off, then we would not be visible because no light is available to reflecting the features. So that's what we could not visualize. So similarly, that some electromagnetic signal is TX is the transmitter transmitting, and then how it is reflecting back, that amount of reflecting back indicate the amplitude, and what is the travel time, that two-way travel time indicate the depth. Okay, so that how it is look like, this is a horizontal surface and one that circular point object. So how the circular point object would reflect in the radarogram, that, and then if the inclined plane, how it look like in the radarogram. So that is the received signal, and straight line indicates no receiving, no reflection, that is transmitting. Okay, so in that way we analyze the GPR. Now coming to the resistivity tomography, that deals with the injection of the current, that it works based on the Ohm's law, that current directly proportional to the potential difference between the two poles. Okay, so that C1, C2 and P1, P2, that C1, C2 indicates the one positive and another negative, that current electrode position. That electrode is nothing but metallic stake, iron rod, just like in the we use for earthing of the earthing of current in a that any electric that connection. So that C1 is the current injection source, and C2 is the basically negative polarity, and P1, P2 is we are measuring the potential just like we measure the resistance or conductivity. We measure who the electrician, who we look for the connectivity, how much voltage is there, is it the wire is connected or not. We use multimeter. Okay, so that similar multimeter used here for measuring the data, and in that way, by multiple advanced data, by microprocessor based instrument, we can utilize multiple data altogether, and then finally we could generate a beautiful image of the subsurface as we are just trenching along a line beneath this profile, and how the resistivity variation is. So this is a data what I remember of some archaeological sites, and this relatively high resistivity zone that indicate some thick that soil mixed with the pottery, and these are the natural soil and these the huge that potteries. Okay, so in that way, based on the resistivity distribution, we could able to infer about the different features in the subsurface. Now I am coming to that first study we conducted in the Lalpahari in 2018. That at the top of this, that we visited, we collected a lot of data. That this was the grid. In the gridded pattern, we collected that ERT5, ERT1, different multiples and cross data, and also we collected magnetic data. That magnetic, that red indicate the high magnetic, that high end in magnetic zone indicate the that brick structure, and in between that blue that indicate the low magnetic, that in between the brick structure, that cell inside the room, it is filled with soil. That soil indicates that filled with soil space in between the cell, that bricks wall, that area is indicated by the blue. So in that way, that we could able to infer different structure before that excavation. Also we conducted resistivity tomography, as we told, that high resistivity, the red indicate that some brick structure, and in that relatively low resistivity, that indicate that in between that bricks wall that fill with the soil. And that also been, this is one another data product using the very low frequency electromagnetic data, and in very this is here that reversal of the scale, that blue indicate the resistive and red indicate the conducting. Okay, so that bricks wall is also identified in the VLF, very low frequency electromagnetic section, and GPR data. That GPR data is basically very high resolution image. It can give that lot of small feature in greater detail. So we could able to identify at a specific depth that small feature that have been identified. Okay. This is another structure for the same that Lalpahari area. Now coming to the that Balgudar site, this is really very exciting that we are here. That what the museum is. This was the ground, that plain ground, and besides still the mound is there. So we conducted multiple resistivity data, magnetic data and GPR data, and then that this is the mound and this is the ground where that museum is presently, and we also collected that lot of magnetic data here and in that upper mound, and we have conducted multiple that geophysical study using magnetic, resistivity tomography, GPR, and very low frequency electromagnetic. And some interesting that features, as I told, that red, this part indicate the part of the mound, and this part, this is a gap, data gap. There is a one slope in between the mound and this land. So that we could able to identify that some high, that specific pattern. This is a elevation map. Okay, so corresponding to the elevation map, if we compare the total magnetic intensity map, so that specific pattern, high magnetic anomaly zone we could identify, and then that have been enhanced again. This is a first data product we collected. Now we did some signal enhancement. After doing some signal enhancement, we could able to identify some circular feature, probably maybe some brick structures, that high magnetic anomaly probably indicating some brick structures, and that blue indicates in between the cell that some soil feature. There is also some brick structures, and there maybe some in between that bricks, that structure or wall cell, there may be that soil field area. Okay, so that indicates huge potential of archaeological importance. As Professor Anil Kumar told, that excavation is really very difficult task, but if we get some idea before going to excavate, then it would be really something that value addition for better excavation planning, before excavation planning. So that compact feature that may indicate some archaeological importance, so that is to be identified with excavation, that what exact the features, but according to the geophysical signal interpretation, high resistivity may be the bricks, maybe the potteries, maybe any burnt or baked material, or some other maybe the that fragments of sculpture, or maybe something different. Okay, that is not loose material, that is compact material. So we could able to identify some high resistivity features, that high resistive features, that stony archaeological features we could able to identify, and in between these are the that what we told, that in between the cell there may be some that soil field area. So these are the different that potential that anomaly seems to be. That again we have analyzed using that in phase one, basically specific component derived from the very low frequency electromagnetic data, and we could able to identify that some linear pattern, the specific linear pattern, they indicate some archaeological importance. and these are the specific location of that small feature of archaeological importance, and these indicates the stratified soil structure. Similarly, there are different that these are the location that specific that distinct reflection pattern in the radarogram that indicates the location and the depth of the different archaeological important remnant in the subsurface. In addition to the that Lalpahari and Balgudar in recent time, it was very exciting experience that that Mithilesh Mishra Sahab and Professor Anil Kumar Sahab that invited me, and with I can see some of other, they helped us a lot to collect the data, to local logistics. Lot of we received, and lot of very warm welcome received. It is really thank you all for the that heritage and that culture preservation that we did. That I am not going through all these. Just before coming, I requested Professor Anil Kumar to enlighten with archaeological importance of this area. Since I am basically exploration geophysicist, I used to engage with a lot of other activities like mineral exploration, groundwater exploration, and a lot of other consultancy project, and I feel shame not to read in detail about the archaeological importance and whatever the geophysical signatures been identified, that to give a one eye opener to link the heritage and the geophysics. That surely I will get the guidance from the Professor Anil Kumar and other that archaeological stalwarts. So this is I just copied from a book. Just I was going through that. This is the that ground of that one school, Nungar, that we collected magnetic data and GPR data. From the magnetic and GPR data, we could able to identify that this is the final data, initial raw data product, that is the total magnetic field. That total magnetic field in an area that indicates that some high and low, that from this we can infer that it is a loose soil or some that debris or something. But these that relatively high magnetic field indicates some things are there, and then we enhance with different other analysis technique. One is the analytical signal of the total magnetic field, then vertical derivative of the total magnetic field. That in general, vertical derivative of total magnetic field is a very efficient tool or approach to analyze the archaeological feature. So from that we could able to identify some specific pattern of the some circular feature, some link, some circular feature. So I expect there should have some subsurface features that may be of archaeological importance. Then we analyze the this is the aerial image taken from the Google map. Then we collected lot of these are the location of the GPR data we collected, and only the red. These are the sections we have presented here. In the GPR is a direct that it gives direct understanding about the possibilities of the subsurface information, and that we get some feature, some overlap features, these are the different structure. That is the P1, then this is P2, here P1, P2, P3, numbers are there. So we could able to identify in all the parallel GPR profiles that similar pattern of the GPR indicates there must be some subsurface features that may be of recent past archaeological importance. Then in further, it was really I am always look for and become excited as Professor Anil Kumar and some local Pradhan and some administration. They helped a lot, and with the excitement of their, and I also excited scientifically to understand what other other archaeological sites in the nearby. Then we visited that area mound that was I think we collected. It was a little late in the evening, till 6:30 or 7. I think it was. Totally dark at that time, but I took a pen with my students, entire team, It's thanks to all for the all logistics. We collected the data, and again in that site, that vertical derivative indicates there are certainly some features hidden in that mound, and also we collected GPR, that this is that root of the GPR data been collected. This is the mount area. This side there was a temple. So in that area also you see some specific features, that specific pattern in the radarogram. So and again these are the small in addition. Just here we are mentioning the big features or big structures of there are some other small features. These are the small features. These are the small features. These are some small features that is hidden in that mound. Now coming to the Rahogan that we collected. This is just nearby the railway line, and I was excited scientifically that in an area there that one elevated land, and in that elevated land there was one totally filled with huge bushes, and that area, as the magnetometer we are collecting the data close to that, and all of a sudden there is a huge change in the magnetic data, and we see that always whenever we are going to collect that area, that indicates some distinct anomaly value, and that value, that vertical derivative, that specific linear pattern. So that must be some subsurface, some feature that indicates the very high, that specific pattern, it must be there in the subsurface that we are getting in all the that magnetic data product. And in that area, these are the different foot track of the GPR data collected, and only few of them we have presented here. And these are the different big structures, and apart from these are the small features, Then switching over to the Rajona, that in Rajona we collected lot of data that from these are this is initial main data product, then another data product that is generated from this TMI or total magnetic field. That red indicate the high magnetic features. That high magnetic features, as I described, it is probably associated with any breaks or any that burnt out material, or it may be any magnetic material, maybe the iron or any other magnetic metal material. So that vertical derivative indicates that specific linear pattern, in addition to the some circular that high magnetic field. So that possibly indicates that subsurface features that archaeological antiquarian or that historical importance. And that area also we collected GPR data, that GPR red indicates the GPR profiles. This is one horizontal slope surface, and there is some small features, and one that dome shape features, that are small features, and then that these are the some circular or some dome shape features. We can see these are the, and similar pattern if you follow the parallel lines, and all the parallel lines, if they indicating the similar patterns, so it indicates it really that there is something in the subsurface, that probably whatever the archaeological that been described in the book that are still preserved, just like a magnetic tape, all are preserved in the subsurface. This is again we collected whatever the data we collected in the Balgudar in 2018, that in addition to that we collected further detailed study using both magnetic and GPR. Earlier we conducted other additional data, that is VLF and ERT, but this time only we collected very detailed GPR. Earlier our GPR was relatively poor resolution, but this time we collected the data with very high resolution GPR, that is high frequency. So we could identify a lot of features in very great detail. So this is whatever the data we collected in that more advanced magnetometer instruments, and we could see that whatever the some linear pattern we identified earlier, same thing still it is identified, and that some the features in the GPRs are, and these are the some very that critical for the archaeology. I think these are the features, small features that are identified, that are relatively poorly resolved in the earlier GPR data. But this is the top horizontal soil surface, this one, top horizontal soil surface, and just under the this is the actual that old historical importance area, and in that area these are the specific location and depth of the features. Then we also collected data over Vrindavan, that in Vrindavan also that whatever the different patterns of high, and that black dot points indicates the point of the data being collected. So that whatever the data being collected based on that results indicate some specific pattern of the high magnetic. In between high magnetic there is relatively low magnetic, so that relatively low magnetic zones are in between maybe some that loose formation or weathered soil covered in between the two that bricks or some other that rocky structures. And also that beautifully that all the structures are delineated in the GPR. You see whatever the features, this is the top soil cover, and this is the feature, this is the actual mound or preserved just like magnetic tape in the subsurface. These are the specific feature, some small feature of historical importance. This. Then Lalpahari, that huge area that initially we visited, that we started a small area, then again we excited that we cover a large area. So this is the entire area. Then for the probably that we'll get some further detailed study for a small area, but this large area indicates some specific that high and low features. That high and low features indicate specific that associated with archaeological importance, and these are the just loose weathered that soil, and these are probably that some important for archaeological aspect. This is, I told that earlier that this is a relatively large area. Initially we started, we covered, and then only small area with high resolution for high resolution understanding specific pattern. That specific pattern we identified, that structures, that high, that if we connect them, we could able to connect. If you see that specific pattern, we could able to some that bricks or some stone that cell, and that are well reflected in the GPR. GPR is a very high resolution, just like a ultrasonography. So that GPR data indicates whatever the different features we identified in the magnetic that are well delineated in the GPR, and these are the some features, small other features. These are the some other feature. Two different domes are lying beside. These are the other features. These are the other features. So that are beautifully identified in the GPR. In whole, that geophysical point of view, that magnetic GPR and ERT methods have excellent potential for identifying the different archaeological features, and that can be utilized to explore for non-invasive characterization, for better planning, better management, better preservation of archaeological sites, heritage sites, for society, culture, society linking, and that preservation, and for tourism purpose. So that for better management and future excavation, if it can be, so that can be done scientifically, what the geophysics non-invasive characterization can give. So that can be utilized as a better ways, and I would be happy to be associate and to work with this team, and it is my really great pleasure. Thank you.